This video is all about solving trigonometric equations. There's a picture of the sine graph there because actually it's going to be more about using the trigonometric graphs. The algebraic approach for solving trigonometric equations is pretty straightforward. It's using the graphs that's the key thing to make sure you have got all of the correct answers. So let's look at the graphs and in particular the symmetry within each of the graphs. So what do I mean by this? Well, the sine graph is symmetrical such that I know that this is going to be the same as this, which is the same as this, which is the same as this. Which is useful because let's say that I know that this angle here is 40 degrees. Well, then I know that this would be 40. And this would be 40. And this would be 40, and so on. So if that angle there was 40 degrees, then I know that this angle here must be 140. Because 180 take away 40 is 140. And I know that this angle here would be minus 220. Because minus 180 take away 40 is minus 220. And I know that this angle here would be minus 320. Because minus 360 add 40 is minus 220. So that's what I mean by the symmetry of the sine graph. Cos graph. With the cos graph, I know that this, whatever that is, would be the same as this. And that would also be the same as this. And this. So let's say that I know that this angle here is 60. Then I know that this would be 60. And this would be 60. And this would be 60. So if this angle here is 60 degrees, then I know that this angle over here is going to be 300, because 360 take away 60. And this angle here would be minus 60. And this angle up here would be minus 300, because minus 360 plus 60. Then we have the tan graph. The symmetry in the tan graph, I know that this is going to be the same as this, which is the same as this and this. So let's say that I know that this angle here is 50. I know this would be 50. This would be 50. This would be 50. So if that angle there was 50, then I know that this angle here would be 230, because 180 plus 50. This angle here would be minus 130. This angle down here would be minus 310. So that is the symmetry within each of these graphs. Let's see now why that's important for solving trigonometric equations. So let's say we've got this equation. Sine x is equal to a half, and I want to work out what x is. Now, some of you might know that straight away, because you're expected to know the exact trigonometric values for certain angles. You should hopefully know that x is 30. Sine 30 is 1/2. If you're not sure, you could do sine inverse with both sides, and your calculator will tell you 30 degrees. But that is not the only answer to this question. In fact, there's an infinite number of answers to this question, which I will show you. Oops. So let me just draw a quick, rough, but accurate sine graph. So my sine graph looks like this. Where this is 90, that's 180, 270, 360, 450. This would be 540. Minus 90, minus 180, minus 270, minus 360, and so on. So what I'm saying with this question is, when does the sine graph equal 1/2? Well, 1/2 is here. And I can see that the sine graph is going to equal 1/2 here, or here, or here, or here, or over here, or over here, and so on, and so on, and so on. You can now see why this equation has an infinite set of answers, because the sine graph keeps repeating. So, your calculator obviously can't give you all of the answers, it just tells you the answer that's closest to 0. It's just telling us the 30 degrees. But that's fine, because we can use the symmetry that we know to help find these other angles. I know that this is 30 degrees. So I know this is 30. And that's 30. And that's 30. And that's 30. And that's 30. So if this first angle here is 30 degrees, then this angle here is going to be 150. Because 180 take away 30 is 150. This angle here would be 390, because 360 plus 30 is 390. This angle would be 510, because 540 take away 30 is 510. This angle would be minus 210, because minus 180 take away 30 is minus 210. And the final answer, well, the final answer on the graph that I've drawn would be minus 330. So all of these are good answers. They are all valid answers for sine x equals 1/2. And if you're not sure, you can always check. You could substitute any of these back into the original equation to check. That's a good way to do this. So it's a good idea. So let's check. If you type in on your calculator sine 510, you do get 1/2. If you substitute in sine minus 330, you do get 1/2. So these are all good answers to this equation, and this is how we use the graph to find all of the solutions that we need, because your calculator will only tell you one of them. So in an exam it will tell you a range of answers to give. So the question might be like this. It wants me to give the answers that are between 0 and 360. Right, so let's solve this equation. I first want to make the cos x the subject. So I'm going to add 1 to both sides, and then I'm going to divide both sides by 3. So I can now do cos inverse to work out my answer. So cos inverse of 2/3, I get 48.19 degrees to 2 decimal places. I am now going to draw a very quick sketch of the cos graph so that I'm able to find the other solutions that I need. I'm going to be drawing my cos graph between 0 and 360, because those are the values of x that I'm asked to solve between for this question. So there's my cos graph. I'm looking to see when it equals 2/3. That's what this question was about. When does the cos graph equal 2/3? I can see it's equal to 2/3 here and here. Using the symmetry of this graph, I know that that is the same as that. So if this is 48.19, this is going to be 48.19. And so my two answers are 48.19 and 360 minus 48.19, which is going to be 311.81. And let's just do a quick check. If I type into my calculator cos of 311.81, you should get 2/3, or certainly something very close to 2/3, because obviously we rounded this, so it might not get exactly 2/3, but it should be something very close to 2/3. Next, this equation, 1 minus 2 over tan x is equal to 4. And I want to find any answers between 180 and 360. So first I'm going to subtract the 1 from both sides here. Then I'm going to move the tan up to the right hand side and move the 3 down to the bottom to make the tan x the subject. Now I'll do tan inverse on both sides. So tan inverse of minus 2/3, I get minus 33.69. Now I'm going to draw my tan graph. Okay. As always, when we're drawing the tan graph, asymptotes go in first. Okay, so there's my tan graph. Right, when is the tan graph equal to minus 2/3? So minus 2/3 is roughly down there. So I've got one solution here, another solution here, and another solution here. Using the symmetry, I know this is the same as this, which is the same as this. Now my calculator told me that this first angle here, this is minus 33.69. So this would be minus 33.69. And this would be minus 33.69. So to work out these other angles, I can do 180 minus the 33.69, which would give 146.31. Or I could do 360 minus the 33.69 to get this answer here. So 360, take away the 33.69, gives 326.31. So our answers are the minus 33.69, the 146.31, or the 326.31, and we're going to give 326.31, because that is the answer that's in between 180 and 360. Let's just do a quick check to make sure that that is all correct. If I type in tan 326.31, you should get something very close to minus 2/3. Won't be exactly, because obviously we rounded this, but that is always a good way to check to make sure you've got the right answer. Right, last example from this video. This, first of all, let me explain what that means, because you might not have seen that notation before. That is cos squared. That means, cos x squared. It's just, as mathematicians, we're a little bit lazy. We can't be bothered to write the brackets. And if we wrote this, that could be confused with being cos x times x. So we don't like that notation. So instead what we do is we put cos squared like that. That means cos squared. Right, so this is a quadratic equation. This is like me saying 2 times x squared plus 2 times something squared plus something minus 1 equals 0. It's a quadratic equation, so I'm going to factorise this if I can. If I can't factorise it, I could use the quadratic formula. But I think I can factorise this. 2 cos x because I know that when I do 2 cos x times cos x, it's going to give me 2 cos squared. Then I think if I have this as being a plus 1 and this as being a minus 1, then the minus 1 times the plus 1 gives me the minus 1 there. That's good. And the 2 cos x times 1 gives me 2 cos x. The minus 1 times the cos x gives me a minus cos x. And the 2 cos x minus the cos x gives me the positive cos x there. So I know that cos x either equals 1/2 from that first bracket, or cos x equals minus 1 from the second bracket. If I now do cos inverse, I find out that one answer to that first equation is 60. And I'm going to draw a cos graph quickly to get the other solution. Okay, so cos 90, 180, 270, 360. So here is my cos graph. You see how quickly it is to draw these things once you get used to it. So when does the cos graph equal 1/2 here? It's going to equal 1/2 here and here. Using the symmetry, this is going to be the same as this. My calculator has already told me that this angle here is 60. So this will be 60. So 360, take away 60 is 300. So these are two good answers to this quadratic equation. I now need to remember that I've not finished. There's this other solution where cos x equals minus 1. So if I do cos inverse of minus 1, we'll get 180. And looking at my graph, there is only one answer where it equals minus 1. It's just the 180. That's the only answer between 0 and 360 where the cos graph equals minus 1. And that's it. That's how we can solve simple trigonometric equations using the symmetries of the graphs.